Let's say your app suddenly gets popular. At first you have one backend server. Every user sends requests to that server. Simple, but then traffic grows. 1,000 requests per second, 10,000. Eventually one server can't keep up, so you add more servers. Now you have server A, server B, server C, maybe 20 of them. Great, but now there's a new problem. When a user sends a request, which server should receive it? That's where a load balancer comes in. Instead of users connecting directly to your backend servers, everyone connects to the load balancer first. The load balancer then chooses which server should handle each request. So the flow becomes user, load balancer, backend server. The simplest strategy is called round robin. First request goes to server A, next one goes to B, then C, then back to A. Simple. But not every server is always equally busy. Maybe server A is processing a huge request while server B is almost idle. So another strategy is least connections. The load balancer looks at which server currently has the fewest active connections and sends the next request there. You can also use weighted balancing. Maybe one server has twice as much CPU and memory as the others. You give it a higher weight so it receives more traffic. But load balancing isn't only about performance. It also helps with failures. Imagine server B crashes. If users were connecting directly to it, those requests would fail. Instead, the load balancer continuously performs health checks. Maybe every few seconds it asks each server, "Are you still alive?" If server B stops responding, the load balancer temporarily removes it from rotation. New requests go only to the healthy servers. Then when B recovers, it can be added back. Now imagine traffic suddenly doubles. Because users only know the load balancer, you can add more backend servers without changing anything for them. 3 servers become 10, 10 become 50. The load balancer just starts distributing traffic across the new capacity. That's one of the foundations of horizontal scaling. Now there's another question. What if your application stores user session data directly on one server? A user logs in through server A, then their next request gets sent to server C. Server C has no idea who they are. One solution is sticky sessions, where the load balancer tries to keep the same user on the same server. But a more scalable approach is usually to keep shared state somewhere external. For example, Redis, a database, or another shared session store. Then any backend server can handle any request. And load balancers can work at different layers. A layer 4 load balancer routes traffic using things like IP addresses and TCP ports. A layer 7 load balancer understands HTTP, so it can make smarter decisions. Maybe /API goes to your API servers. /images goes somewhere else. Requests for one domain go to one service, while another domain goes to a completely different service. So the easiest way to think about a load balancer is this. Your users see one entrance. Behind that entrance, you can have hundreds of servers. The load balancer decides where every request goes, avoids unhealthy machines, and helps spread traffic across your infrastructure. It doesn't make one server more powerful. It lets many servers behave like one system.